Hello, this is BN304 industry-based project. I'm Manushi Khatsuria. Our client is BRR Technology Solutions and the agent is CareerDC. Now I'll introduce you to my fellow teammates. They are Akila, Isuru, Thushitha, Suvarna and Sovit. So let us move towards the introduction of our project. So basically the design of our project includes the designing of a cooking system out of which the customer can keep the record of the amount of gas which he has used, and the built-up system also comes with the transmission of the collected data to the platform, to the cloud-based platform actually, which will store the data. So the online payment gateway system is also embedded with the website, so in which it will enable the customer to make the online payments according to the usage of the gas they have done in a certain amount of time, which can be like monthly or weekly or whatever it is set. So let us begin with the details of the project. So the title is Cloud-Based Cooking and Heating Gas Meter Consumption. And it involves the design of the mechanism of the gas meter in such a way that the recorded data gets stored in the cloud-based platform. And our goals also included making of a payment gateway system, which will allow the customer to make online payments with the help of their credit or debit card, and along with that, after the payment is done, they can get an instant notification that the payment has been successful, and then the meter would be like the meter readings would be set to 0 once again, which would be like a reset. So this project was divided it into 3 phases, and each phase included the research about the project, and then the data capture as well as the design model respectively. So let us move towards the problem domains. Basically our project emphasized on 3 type of questions. So first thing was to find a suitable cloud-based platform and the necessary devices like a programmable or smart gas meter, an actuator or something like that. And the next thing was to make a payment gateway system. So basically we haven't used a real payment gateway system. It's a dummy one, but it can actually like show how the payment will be done in our website. Along with that, there will be an instant bill, which I, as mentioned previously, would allow the customer to make sure that their payment has been done successfully. And the last thing was to create an e-receipt, after which the readings of the data will be the readings of the meter actually would be reset to 0, and then they can start a new one. Thank you so much.
Hi everyone, my name is Suvarna and I'm going to talk about the present gas consumption recording systems available on the market based on our literature review. So there are numerous gas consumption recording technologies made by different companies like ABB, Acra, Landis plus GYR, which are used across the world by gas providers. These gas monitoring systems normally provide the reading monthly or once in 3 months or annually or sometimes once or twice in a month. Most of these systems lack real-time gas consumption recording system. Most of these systems use wired connection instead of wired connection. So talking about the project planning, this is our proposed use case diagram, which represent the user interaction with the system, that shows the relationship between the user and the different use cases in which the user is involved. And now this is our Gantt chart, which is very useful in breaking down our whole project into several subtasks. We can see how much of work is completed and all the scheduling and deadlines in this chart. Now talking about the project expected outcomes, when our project is completed, the final system should be able to read the gas meter in real time. It should be able to convert the gas usage into appropriate unit and create a bill accordingly, which can be understood by the customers easily. It should be capable of transferring the data into the cloud, and also should be able to provide a convenient payment gateway from which the customers can pay their bills. Now I'm going to talk about the high level design. After all the research, discussion and observations of the present smart meters available on the market, the smart gas meter that we choose and are currently working on has the following features. At first, the smart meter reads the gas usage and provide an analog reading. Thus, the reading thus created by the smart meter is converted into the digital reading by a converter. Then the data is transmitted into the computer using wired connection, and from there the data is also circulated into Python programming, where it converts the meter reading into unit and unit consumed by every individuals. And such data is also stored in the Google Cloud using wireless communication. We have created a separate web page so that the customers can see their gas usage and pay their bills using their bank card. This is all from my side, and now my fellow member Thushitha will discuss about the hardware and software used. Thank you.
Hello everyone. Today I'll be talking about the hardware implementation of our project on behalf of my project team. In next few minutes, I'll be explaining about each and every one of these devices. I'll name these devices to start the proceedings. Here we have our air pump and pulse output gas meter, and here we have our omnimeter, and last but not least, we have our USB converter. As my teammates mentioned earlier, our main objective is to capture the domestic gas consumption. In case of that, we have to deal with a real gas line. But under the rules and regulations of the Australian government, we are not allowed to make any changes of a real gas line. In case of that, we have to stick with substitute. So here is our substitute. It's an air pump. This works as pretty much the same way as a real gas resource. So here we have our pulse output gas meter. This works as a regular gas meter, but it has the ability to produce pulses for each and every cubic foot of gas that has been recorded. And here we have our omnimeter to read the pulses which produces from our gas meter. And most importantly, this device can read pulses from 3 pulse output devices at the same time. And here we have our USB converter. Without this USB converter, we won't be able to make a successful connection between all these devices, because this USB converter converts RS485 signals, which comes from our pulse output gas meter, to a signal which can be understood by our PCs. That's why this USB converter is so important. So that's the main functionality of our hardware implementation. Now I'll be showing you the function of these devices. First, I'll turn on the air pump, which we assumed as the main gas resource. As you can see, the pulses are being made. It means the pulse output gas meter captures the gas successfully, and as soon as it captures the gas consumption, our omnimeter will read the amount of gas and sends it to the USB converter, and the red bulb indicates the successful readings. And that's all from the hardware device implementation. My fellow teammates will talk about the real-time database and the web portal in the upcoming sessions. Thank you for joining.
Thank you, Thushitha. So now I'll explain the back end of our system. So this is the Python application we are using to extract the reading from the pulse reader, and push that reading into our cloud application, which is based on the Google's Firebase platform. The application itself is not that complicated since there's an existing Python API made by EK Metering to help extract the data from the pulse reader. We just needed to make some modification to get our desired output. And few things I should mention. Firstly, each pulse rate from the meter is equivalent to 1 cubic foot of air flowing through the meter, and we have converted that into megajoules in this command line since that's the standard of measuring natural gas in Australia. And also we are using this variable called the meter address to differentiate each customer. This 9-digit number is unique to each meter, and when a customer is creating an account on the web portal, the customer can set his meter address so that the data extracted from that meter can be directed to his specific account. So that's the back end of our system. Now my colleague Isuru will explain how a customer can interact with the web portal and the outcomes of our project. Thank you.
Thank you, Akila. As Akila explained earlier, after reading the gas meter, the data is sent to the cloud, so any consumer can log into their account via a web browser and check their current usage and make the payment. I'll now show how the front end works. So this is the login page. Consumers need to log in their using their email and password. Here we can see the current usage, total usage, and amount to be paid. As it was mentioned earlier, it is being updated in real time. From here, you can directly make the payment from the payment gateway. You just have to add the card details. So after making the payment, you can now see the amount has been paid and it is been updated as 0. So this is the basic process of our system. It brings us to our outcome now. Our expected outcomes were updating customers' current usage in real time and letting them able to check their bills on the website and make the payment online. So as I demonstrated earlier, we have met the expected requirements. And now I'll invite Sovit to continue the presentation.
Hello guys, I'm Sovit Khadka and I'm presenting on reflection on the work by this project. This project BN 304 and BN 301 was immensely useful and practical to understand what we have studied in Bachelor of Networking with more depth. It has given an opportunity for increasing our ability of doing research and developing ourselves in this field. It has provided us knowledge in our practical and demonstration ability. Apart from that, we have also understand how to work in a group, participate as a group. So it has developed our individual ability as well as ability to work in a group with other members. This knowledge will be helpful in our future courses and career in this field. Thank you so much.